All right. Good morning. Good afternoon. Good evening. We are live. Can you all hear and see us and everything? Supposed to see the chat here. Oh my God. We are. You know, we're at Devoxx Belgium. We did this a year ago around this in the same conference, maybe even the same room, or maybe it was next door, but it wasn't all that far from here.
Yeah, that's very close.
You know, the question that I think is on everybody's mind is, where were you when Mario open sourced his hair?
I was in the room. Yeah,
Right.
It was really exciting.
Right. For people wondering what the peak of Java conference life is like, it's, well, somebody lost some hair and
yeah, it was creative. It was like, well, it showed real change, you know.
right.
because you have real change in the community.
Right. Is that the message? I don't even know what the context.
No, that was the message. That was the message. That was clearly the message.
So my understanding is Brian Getz, Java language architect, Brian Getz was doing a thing, and the whole theme was progression and change and whatever. And then to
Yeah, and
demonstrate
Mario
that.
Fusco thought, yes, I'm gonna show you real change.
Mario Fusco is our friend. He's a fellow Java champion, and he famously has had these long locks of hair for as long as
Very
I've ever
long
known
time,
him.
yes.
Yeah, I mean, just down to his back and everything. Yeah, I mean, yeah. So he cut his hair on stage yesterday. I mean, I think other things happened yesterday. I don't remember. I just remember that. That's what I'll take away from this year. So help me change my mind. What did we? I mean, I know you are here. You're Thomas Wuerthinger.
Yes, Thomas Wuerthinger. That's right.
Is that
Very
right?
good.
Are you
Yes.
mocking me or like?
No, that's correct. That's very good. For an American, it's very good. Very good.
There it is. It's the asterisk, like for an American, which is fine. I'll take it. It's since I am one. Yeah.
That's right.
Wait, no. So what is? How would like a proper German pronunciation of that be?
No, Wuerthinger.
Wuerthinger.
It's a little bit harsher, but in German, but it's good. It's
Okay,
good.
such a nice language. Okay, great. So you're like the vice president or senior vice president at Oracle, and you're the founder of GraalVM, which is all the rage these days, right?
Yes, I'm the GraalVM project lead, and I'm super happy that GraalVM is still very active here, even at Devoxx. I was like,
oh yeah,
when I saw that Devoxx, like Word Cloud and GraalVM was the same size as Spring Boot, I was
Yeah.
like, that's cool, and that's probably thanks to Josh talking so much about GraalVM.
Well, and you and Alina, she's doing a great job.
Yes,
Yeah,
absolutely, and we had a joint session with the Spring Security lead as well,
Right.
and it was very good.
Oh, you mean Daniel?
Yeah, Daniel. He was wearing this shirt. It was like Spring Chief Security Officer.
Right. Oh, he's not the lead, but he's a very prolific contributor.
One of the Spring.
Right.
Spring has many security officers.
Right.
So he's a Spring security officer.
Right.
That's
He's Daniel Gagne Moirot is just amazing. And we did a talk together on passkeys. You know,
Right.
like you can. That's another. We were talking about just a minute ago. We were talking about how there's freaking laser beams to cut your eyes into better shape, so you
Right.
can actually see better. And there's pills you can take to lose weight, and like we live in an age of miracles. And then the thing that broke my mind was I can now use a browser, even Chrome, and use my fingerprint to log into a website. Right. That's oh my god, we're living a. I mean, you couldn't have convinced me of this possibility 28 years ago. Anyway, so you're Thomas Wuerthinger
Yes.
with a T, and you're the GraalVM, and now we have this incredible showing here at Devoxx.
Yeah, but
It's
the
a known
Devoxx here,
commodity.
I had a talk that wasn't even much about GraalVM. I was talking about the 1 billion road challenge.
Right, that's another thing.
That was my most favorite conference talk that I gave so far, because I had 3 hours and I could like talk about the very low levels of assembly language, compiler graphs, perf tooling.
And that's recorded. Wait, before we get into that, one BRC, our friend
Yes.
Gunnar Morling,
Yes.
asked the community. This is in January, so actually this would have been after we last convened here last year.
Right.
He asked the community last December and early January this year, submit a program to process 1 billion rows of weather station telemetry data. So city,
Right.
semicolon, and then the temperature, right? And there's 1 billion rows, which amounts roughly to 13 gigabytes
Yes.
of text.
Yes.
How quickly can you write a program to ingest, process, and then dump out some information about that data and then exit?
Yes.
And I talk about this in my talks these days, and I ask people like, how long do you think it takes? Right? Do you ever ask people? I get wildly divergent numbers. I get like
Right.
10 minutes, 15 minutes, 20 minutes, an hour. You know, like people really think it's
Right. It takes a very long time.
yeah. And also it's 13. It's not like you can just load it all into RAM, right? Unless you're
Yeah,
using Azul, I guess, with their 2
Right.
terabyte whatever addressable RAM. But for most JVMs, and that was the rule, you couldn't use
Right.
frameworks or libraries. It is just stock
Right.
standard JDK
Yeah,
stuff.
just stock standard Java. How fast can you do it? And it was surprising in the end. Yeah, it was really surprising. On a stronger machine, like on a 32 core machine, we got it down to 300 milliseconds.
Yeah, so yours was the leading entry. Yours is the
Yes.
number one
Yes.
fastest response, but it was by a hair, right?
Right.
Because by that point, the top 3 were all even the
They were
top
all
4.
very close together. And also, to be fair, like during the contest, all the contestants were like taking the best ideas from each other.
Yeah, and
It was more like
iterating.
a community effort, yeah, and
Yeah.
they're incorporating the ideas of others. And so that's why also some of the top solutions are
multi-author.
multi-author, right? Yeah, also my solution here is multi-author. And and that's also why they're close together. But yeah, it was a very close race, and it was
Really fun.
was on the last evening,
Right.
like on the last evening, like like our solution was leading the race.
It was 31st of January.
Yeah,
right?
31st of January was the deadline
Right.
for submissions, right? And I'm 31st of January evening, solutions leading the race, and I'm like just chilling here. It's like, okay, let's just chill and let's hope nobody kind of does something crazy.
Yeah.
But then suddenly, like, there was a solution that got even faster. I'm like,
no.
damn it, so close before the finish line, and like you don't want to like.
You can't just leave it, and now you got to fix it.
No. I mean, you are a little invested at this point, and so close before being taken over, so close before the finish line. It's yeah.
So
and that's when in the last few hours, I was going into program competition mode.
Yes.
But I was like, because when I was young, I was doing a lot of program competition on ACM contests
Sure.
and IOI, and
Yeah.
so that really got me like so excited about the contest. But like more like I was feeling young again.
Right. I mean, you and Roy and a bunch of other, big names, luminaries in the community, all submitted submissions. I mean, Gunnar started the things off with like a naive but workable.
Yes.
Like this is a.
It was very nicely. It was a very small number of lines of code, right? And that's also what you could see over the course of the competition. Is kind of the programs got faster, but they also got like substantially more complex. Like the lines of code like going up a lot.
So let's talk about that in a second. Yeah, I mean, so that. Ignoring GraalVM for a second.
Right,
the first three entries were all better for their use of the GraalVM native image technology, which is awesome. But even the fourth one was like 1.8 something, and it was open JDK standard. Did I just have a stroke, or did that just disappear for a second?
I think it was just
a
glitch
in the matrix. All right, fine. Well, anyway, that the results were freaking amazing. 1.5.
Yes, 1.5 seconds on the benchmark machine.
Yeah.
And the benchmark machine had 8 cores. So on an 8-core machine, it was 1.5 seconds.
And that's single threaded? Or what was that?
No, that was multi-threaded, but
okay.
it's 8 cores, like eight threads in parallel.
Right.
But on stronger machines, we got it even down to like 300 milliseconds. So it's like
what the fuck?
Yeah, and this just shows how fast Java is nowadays, even for a task like that.
Yes. Well, I mean, I talk to people, so I do in my talk these days. All right, I ask the question: is the solution efficient? Well, then we look at the energy efficiency for, and that's from 2018. I know that we talked. I know you guys did some subsequent refinement on that, showing energy usage for native image.
Yes.
And that's kind of that's hinted as a possibility in that original thing that I keep surfacing from 2018, because they show top 5 languages. Java's the 5th. The first 4 are compiled.
Right.
And the 5th one, Java, is the virtual machine. What would happen if it was compiled? And of course, we know.
Yes, it says energy usage gets much better, because typically when you start up a Java without EOT compilation, then on every startup you will pay the cost of JIT compilation.
Right.
And that's a very complex operation, specifically if you have a large Java program, and then there's a lot of code that needs to be compiled.
Yeah.
And you're shipping every time it's starting up, right? So and typically you start up applications more often than you ship them. So
So it's you would know, of course, because you worked on the JIT for. I mean, that's what GraalVM started off. It's one of the things that people.
Yeah, GraalVM started off as a JIT,
right?
And I worked for the largest part of my career on JIT compilers and making JIT compilers better, right? But it's a thing that, like, if you study something for a very long time, you know a lot about the disadvantages. So, and that's why I later on when we started to do the EIT compilation, and we figured out more and more advantages of EIT compilation, and because with EIT compilation you are more predictable. For example, I think it's an underestimated factor. Like if you run the program multiple times, the variance is going to be much lower, right? And
because it's kind of entropic, really. Like there's heuristics in the JVM, and you assume that they're going to arrive at a consistent result, but it's not always the case.
Exactly, because the JVM takes the profile from the beginning of the app, right? And the profiles can be different a little bit each time you start it. And this is why when you start a Java app multiple times on a JVM, you will get much more variance in results. Now, of course, the advantage of the JVM here is, well, you get profiles.
Yeah.
But that's why for native image, we added profile guided optimizations, where you can actually profile in your test environment.
Yeah.
And you get like a profile file and still feed it into the EIT compiler. And that's what makes it really competitive.
And so, okay, people are saying, well, that's the commercial edition, but it's free and you can use it for Is that still true? You can still use it.
Yes.
You can use it
Yes.
for whatever you want, right?
Yes,
Like,
yes. The Oracle GraalVM edition, which is the standard edition, this is the
Right.
one we recommend anybody to
Right.
use. It is free to use also for commercial purposes. Absolutely.
Yeah.
It's the GFTC license, which is the Graal Free Terms and Conditions license.
Nice. Yeah, it's got its own license. That's how good it is.
Yes.
Okay.
Exactly.
So that's and by the way, that I think is going to become the way of the Java programmer eventually. Is, I mean, if you look at all the sort of prevailing ways to speed up your program today, obviously in the OpenJDK JRE world, we've got the and off on the distant horizon there, we've got Laden,
Right.
and that's basically you do a training run and then you use that to supplant the data to speed up the running of the program.
Yes. There it's a training run. For us, the training run is not necessarily required.
Right.
You can do a training run to get PGO data, to get profile guided optimization data, but you don't have to do it, right? So that's and you're kind of guaranteed the result there, right? And
GraalVM and Crack too, right?
Yeah. Crack also needs to have a training run, right? And what this also means is that the deployment size, of the app gets larger because of it. Because you need to essentially both ship the app itself, and you need to ship the cached data, right?
Yes. Well, so that and the complexity of that is, it's you have to test it in the same environment as well. You have to the capturing of the profile guided, the capturing of those training runs on those other technologies. Really, it's important to do it in the same environment.
Yeah, exactly. And so that's in general. We see training runs shouldn't be required in our view, and that's why native image works also without a training run, right? But one thing we're currently developing native images is very new, and it's therefore it's not yet in production release, but that's kind of the direction we're going in. Is like with native image, we try to always remove redundancy, so we are not JIT compiling every time the application starts.
Right.
But currently, when you compile a large Spring application, we are EOT compiling the whole Spring framework.
Right. And that's why it takes a little bit longer than
and that's why it takes a pretty long time, because Spring framework is very big, very sophisticated, has a lot of functionality in it, and most of the time we spend when compiling a Spring app is compiling the Spring framework parts.
Right.
And therefore, one of the things we're developing currently in native image is what we call layered native images, and this is where you can create a base layer.
He's talking about it.
The base layer that is the Spring framework layer.
Yeah.
And that's going to be pre-compiled, and then your application becomes an extension layer. And that extension layer is then much smaller and builds upon the base layer. And when you then change your application, you don't need to rebuild the whole Spring framework.
Yeah, you benefit from the computed index.
Exactly. It's all cached for you.
Oh,
and this should then make the developer experience much better.
Right.
Now, this is a technology which is, the team is working very, very hard on it. Right. And we try to get it out as soon as possible because Josh really wants it.
I really want it, but also I'm willing to wait if I need to,
Yeah, exactly. But that's why we're really trying hard to get there, because that will then make the development experience much better.
Right.
And the additional benefit is if you then have multiple apps and you deploy them, they're gonna share the same base library.
Right.
And that gives you memory savings, huge memory savings.
Yeah, because you can. It's like a Docker layer as well.
Yeah. And also for Docker image sizes, it's also substantially smaller because you will have a base Docker image with your Spring Boot layer, and then you have the app layer on top, right?
Yeah.
So we really think this will be the next step, for native image, and sort of be a first step forward, because for native image itself, yes, we can make it a little bit faster still, a little bit smaller still, like some smaller incremental improvements, but there we are already really, really good. Like we showed that the peak performance with profile guided optimizations is practically the same, sometimes even better.
Right.
So there's no more downsides from the operational characteristics. The only downside currently for native image that you have is that, yes, you need to build the image. At build time, you need to invest more CPU cycles. But to be fair, it's typically much cheaper and easier to have CPU cycles at build time,
just
than at deployment, when you actually run the app in production, right? Because you need to think about it. What you do there on your computer, is what otherwise would happen on your cloud production instance, which is going to be much more expensive to run.
Although I will tell you, contrapoint,
Right.
if I may, I believe that as we get more predictable results from these native image compilations and it becomes more of a known commodity and we can trust it more, it's absolutely one of those things I'd like the platform to do for me. And so Cloud
Yes.
Foundry actually has the ability to do native images. You give the platform a
Right.
jar,
Right.
And it'll deploy a
Yeah,
native image.
so Cloud Foundry will do it automatically for you.
Yeah,
That's
the
cool.
thing. Yeah,
That's
and
very cool.
we have a build pack that'll do that. So like, yeah, because
Yeah,
I need to get it.
that's true. If you can hide it behind the platform, right,
Yeah.
where the developer uploads the jar file and it does it for you, that's of course really cool.
So
Yeah.
And so anyway, yeah, but I take your point. You don't want like having to figure that out, and if you have to do it manually, it's extra work and it's going to be inconsistent and all that. So so we agree. So GraalVM really energy efficient, and we saw that that table from years ago that looked at Java. Now we have native images. What do we have any idea of like what that is? I mean, that's even faster, right? Even more energy efficient. Do we have any like numbers and joules and things like that, or is it just
well, I mean, it's difficult to give exact numbers because
Sure.
it depends on the machine and so on, right?
And the program.
But it's certainly the case when you benchmark your program and you benchmark just the CPU cycles.
Yeah.
It's much smaller because so it depends really on how long and often you start it, etc.
Right.
Now the main thing people are using it for, like one main thing is serverless applications.
Oh yeah.
Running Lambda and so on, right? And there the startup is paid every time you invoke the function.
Right. Oh, that's true. And because you can't amortize it over the run. That's the whole point. It scales to zero. So
yeah, and there's technologies like where they have like the snapstart, for example,
Right.
but like even snapstart cannot get it as small as native image. So native image is a technology that would also beat in startup on AWS Lambda the snapstart.
Oh yeah. So I didn't know it was faster because Snapstart uses Crack, right?
It uses a technique integrated similar to Crack that's integrated in the AWS Lambda platform.
Yeah.
But native image is still better because
for energy, you mean? Yeah.
Not only for energy but also for startup because it's for startup time because the Crack image is a pretty large.
Yeah.
And so you need to load them, and with native image the container size etc. is small.
Okay, so I that I can see that. My off the cuff sort of experiments have shown me like Crack can be a little bit faster sometimes, but you're shipping the whole JRE, so you don't get any of the RAM benefits that you get with native image, right? You don't get the energy efficiency. And by the way, the energy efficiency, if you think about it, right, the JIT is like a C++ compiler. Do you really want to ship a compiler with your Java program every single time, right? Like
right. And when you in the Docker image, like when you scale up and down, for example, like the Docker image needs to first be transmitted to the machine that should run it.
Yeah.
Right? So the deployment size aspect in many of these systems, also serverless systems, are playing a role when it comes to the startup question, right? And that's why deployment size can be an issue, and that's why native image is also great. But
I love native image.
Yeah, and I mean the thing is, Alina gave a talk with the security
Daniel Gagne,
the security guy from Spring, right? And that's an area I think that's also a little bit underappreciated, is that, well, native image, people say, oh, it's bad because it doesn't support all of reflection and crazy things that Java can do, right? But that's a bug, yes, in some sense.
Well, but it's
also a feature. Yeah, exactly. Because
in
your application, you don't necessarily want that arbitrary reflection taking place. And if you look at some of the biggest issues that are like security issues that came up
in this area,
Log4j, for example, exactly. So they're based on the fact that somebody's exploiting that arbitrary reflection is possible,
right? And
so it's a real security benefit for your application if you can actually restrict reflection, and you will have the include list of what is reflectable. And this kind of makes this application more secure. And therefore, like the fact that native image does not support all arbitrary ways to do reflection is a security benefit, and the additional effort that it takes for developers is, I think, well invested.
And by the way, this is where I think you benefit from low level layers of abstraction, right? The cloud platform beneath the framework, and the framework can do trust me, friends, when I say making Spring do this for you in the 99% case was an hemorrhoid-inducing, agonizing experience. But you don't have to pay that cost anymore. We have people who have lost all their hair, but it's fine now. It's done. Like, you can take real workloads to production on this technology, and I do it all the time, right? I'm a big fan. I have a lot of software that I maintain for myself. That's all built in Spring naturally. And one of the projects I've embarked upon over the last several years is moving them more and more to native image. And at first it was like, okay, I better like patch this. I got to do that. Now I've stripped all the custom hints. It just works. I've got like Lucene, and I've got like just weird libraries, things that PDFs generation and things like that.
Yeah.
It not just Spring, it just works.
Yeah, no, the support in Spring for native image is already really great.
Yeah,
and even with third-party libraries, it's getting better and better, because over time we are very active in the ecosystem to try to get libraries adopt to this type of approach.
Right.
We have a metadata reachability repository where for common libraries, the metadata is already there.
Yeah.
And we just hope that the Java community as a whole is gradually moving even more to a system where it's just a standard for any library to support this.
I mean,
and it would be an exception for a library to not support this. And we're very close to that. We're incrementally getting there. And so from that perspective, it's one of the things that really kind of like, I mean, I was on Twitter, this one guy tweeting about how Java is not good for command line applications because the startup is worse than C and Rust or whatever. It's a bullshit.
Yeah, nonsense. Like, just use a native image. I do it all the time.
Yeah,
and we have really nice abstractions for building CLIs these days.
Yeah. And so for Java to be competitive in startup and memory with these technologies, like native image is a perfect solution for that.
And it takes you to places that you couldn't get to. I talk about Kubernetes operators.
Right.
You can build that with native image. I help contribute the support for that, and so now you can use the official Kubernetes Java client, build a Kubernetes operator, and it's just as at home in your Kubernetes cluster as anything in Go.
Yes,
it's awesome.
Exactly.
So we agree. Energy efficient, great. Is Java scalable? Of course, we got virtual threads now, which is like boss software, amazing. I'm actually sniping at people metaphorically on Twitter right now because I'm like, look, other languages, you really need to catch up. It's embarrassing for you. It's ridiculous. You should learn what Java did. This is the one time,
right?
Okay, where we can say Java did the better thing. So I want people to just enjoy this moment in the sun. It very rarely happens where we can be high and mighty, even if not particularly well deserved. This one time, okay? Like I'm not gonna sit here and say that Java is the most beautiful language, but we got this right. We got virtual threads. It's an amazing win. Yes. And so then the final thing is it fast? And this is where we get into the 1BRC thing,
right?
So GraalVM, your examples, all the fastest top 3, all benefit from GraalVM. But again, the fourth option is only like 0.2 or 0.3 seconds slower. It's like 1.8 versus like 1.5 or 1.6, right? I forget the third digit, but
right, yeah. But that fourth option uses custom vector API,
right?
And we actually it's a preview feature, and unfortunately, we are in GraalVM with the JIT compiler. We at the time of the 1BRC, we couldn't handle those constructs that well.
Yeah.
In the meantime, we have actually improved this, and my team is telling me that if they're taking that fourth solution and run it on their patched version of GraalVM, they make it faster than my solution.
No.
So now I have to decide whether we're gonna release that, but unfortunately we probably have to. But so the reason that could compete was because of very sophisticated vector code, right?
Right.
And it's true that Java, if you look at also the solutions in other languages, if they got faster, it was primarily because of custom vector API stuff, right?
Yes.
And we are now working very hard at the GraalVM team to implement it too. And the best thing is I hired another expert, which is Kuan, who is the guy who came up with the crazy temperature parsing for 1BRC. We hired him into the GraalVM team, and he's helping us with the GraalVM vector API.
That was like a month or two ago, right? I saw it on Twitter.
Yeah.
I'm so glad. Yeah.
Yeah, it's really cool, and we are super glad to have Kuan on board and to have him on the team and help here make Java faster.
Right.
But you have to say, when you look at 1BRC, as the top solutions, they're kind of really very specialized.
Oh.
But if you take one of the very, it's an understatement. But even if you take a solution that's more reasonable, right, and it's simpler, if you run it on the GraalVM JIT, it runs faster.
Yeah.
And this is why, if you look at the participants like almost all of them, like the 90% of them were going to the GraalVM distribution.
Right.
And that's really cool for us to see, because we worked very hard on this compile
It's free
optimizations.
speed,
And it's free speed. You only need to change your JDK distribution there, and you get the free speed.
And set up the native image pipeline. That's
but even without native image.
Oh, just the JIT.
Just the JIT, right? So those solutions, I tested it, and it's only when the solutions get into the 4-5 second range.
Yeah.
So it's maybe the top 20 solutions get faster even with native image, because then the startup kicks in, right?
Yeah.
But for the rest of the solutions, the Graal JIT will be the fastest way to run it, and you don't necessarily need native image. But then if you go like into the very smaller parts and you want lower memory footprint, then of course it's interesting. But just Graal JIT, and Graal JIT definitely is a drop-in emplacement for your Java applications in all scenarios.
Does Twitter still use it? I remember X or whatever, like I remember years ago, Chris Tallinger and the.
I suppose they probably still use it.
Yeah.
Because they still use our free version. Yeah. Exactly.
Okay. I don't know.
So,
that JIT is. That was really interesting even 10 years ago. I remember learning.
Yeah. No. Twitter was running theirs because it's specifically good for complex code, and Scala code is kind of complex code typically.
Yeah.
And so therefore Twitter was already 5-6 years ago starting to use Graal in production, and I'm pretty sure they're still running it.
Cool. It's a the website's not. It's a husk of its former glory, but technologically you want scale, right? It would be silly to dismiss that.
Right.
Okay, so tell me about we agree you get free speed from both the JIT and the native image stuff, but that wasn't where you stopped with your solution. You did a few other things that were insane.
Right. Yeah. That's true. And the 1BLC solution. Yeah. One thing was at some point, like I was using Linux tool to benchmark my native image, which is a very nice thing, by the way, because you can now use perf and all of the low-level profiling tools for your native image, and very show you things that a Java level profiler doesn't show you. And one time I was benchmarking my solution. I was trying to squeeze the last milliseconds out of it, and I look at the perf profiling graph, and I see like my threads of Java doing their work, and then they kind of finished. And then I see like 100 milliseconds where no Java thread is running anymore, but it's spent in the Linux kernel. And I'm like, oh, what is this? Right? I was like, why am I spending 100 milliseconds in the Linux kernel after my Java threads did their work?
Right.
And the problem was that during the unmapping of the file, you would actually, the Linux kernel would single-thread it, set the contents of the file, probably for security reasons,
right?
Before the process exits.
It would what?
It would do single-threaded overwrite the file contents. It would overwrite it. It would sep it. Sep.
What is sep?
Sep. Maybe it's a more compiler construction term, but it's something where you sep a memory area. You just write something over it.
Okay.
And so there you just make sure that the file is no longer in the physical memory after the process shuts down, right? You overwrite the contents. And you would do this single-threaded, and this was a major bottleneck, right?
Sure. So the operating system itself is slowing you down.
Yeah, exactly. And like Java was very fast, but the Linux kernel was the problem, right? And then like, okay, should I go on the Linux kernel mailing list and submit a patch?
I'm sure Linus would appreciate it. He's receptive to criticism.
Yeah, that's right.
Famously.
That's right. So I was like, okay. Probably not an option.
No.
So that's why we then use the Java process API to start a second process that's hiding this unmapping stuff, and then just coming back. But this is just another example where if you use sometimes the profiling tool of the operating system, they can give you some insights in that you wouldn't otherwise, right? And the second very interesting thing that I learned during the contest, which it was clear to me that branches that are mispredicted are bad on the processor. Like the processor always tries to run the stuff and it tries to predict every branch, but it wasn't clear to me how bad they are, right? It was like crazy bad. And this was the last change in the solution where I made the solution more branches, and the solution does more work.
Yeah.
The solution would actually probably consume more energy because you actually are running more instructions.
Right.
But it runs in less cycles because the Intel can just saturate their pipeline better.
Oh.
Because otherwise it would stall out for the branch misprediction.
Right.
And this was also very insightful. And based on that, we are now in the Graal JIT compiler. We are trying to add more optimizations that are removing branches because branches are
bad.
if they are mispredicted. If they are predicted, they can be very fast on Intel. So if Intel processor gets the prediction right where the branch is going to go, they're going to be very fast. But if they're mispredicted, it's terrible.
And this is also, I mean, there's some work right now to realign Java with the reality of the modern day hardware, because back when Java was written and first debuted, some of these things weren't necessarily God's truth, right? But now cache misses are much more painful in certain cases than they used to be. And so we have things like Valhalla for, like, it should be very easy to store small amounts of data quickly and access them quickly. But if there's a whole object header and a whole object graph associated with everything, it becomes very hard to keep that compact in memory.
Exactly. Yes.
And then same thing, that SIMD stuff, the vector API.
Yes. Also, yes. The hardware definitely has changed a lot, and that influences the heuristics that the compiler will do for you, right?
And
or in this case, the branch misprediction have gone probably worse over time, because when the processor can do 3 instructions in one cycle in parallel, then missing out on some cycles can be very painful.
So you managed to steer your code and therefore inform how the hardware should evaluate and work with your processes, your instructions. But not everybody's going to be able to do that. So, because most of us don't care that deeply about the internals of the kernel.
To be fair, for most programs, you shouldn't worry about it.
That's what I'm saying. I like that GraalVM does this for me.
Exactly. GraalVM does it for you, and that's why, I mean, for me as a compiler constructor, I think it's interesting or important that I do this type of experiments. And I learned from participating in the BombRC like a lot. And so, but then, like, the compiler constructors and my team of compiler engineers, they're gonna try to now take these learnings and put them into compiler optimizations such that your Java program will run faster without doing anything.
Look how happy he is.
So
I want people like him working on this stuff. I don't want to work on it. I have such a small amount of hair left.
Well, that's what all our job is about. Like, you're very happy if you can make your program run faster without you thinking about it.
And I love that.
And it's just in Native Image recently we had a very talented PhD student in Czech Republic. And he had like this pull request on Native Image because he does a PhD on improving our static analysis.
Wow.
And he's like, oh, I could improve the size of your native images by 5% across the board. And we're like,
what?
That's crazy. 5% for everybody. Okay?
What? How?
That's really cool, because they make the static analysis more precise, and they can get out some more. They can figure out more of the program that will not be used at runtime.
And it doesn't break anything?
No, it doesn't break anything. And for any Spring Boot app, 5% smaller images. I'm like, that's a good win. That's a really good
disk?
That's disk.
That's so cool.
Yeah, but it might also partially make the RAM smaller, but
you're loading slightly less memory.
Exactly. But it's primarily the disk thing. But it's just crazy for us. It's 5% and for everybody, right?
Yeah.
And then so for us, it's off, and it's like our work is about 1% here, 1% there. We're super happy because it scales. It scales to any program.
So so native image, like, okay, again, this is still a lot cheaper than shipping a whole Jerry and your class path and all that. But my native images are about 100 megs, typically, to do something interesting. 5 megs. Across 10 builds. Or 100, 20 builds.
Yeah, absolutely.
That's another deployment. That's a whole Docker image I don't have to deploy.
That's and that's what I'm saying. I mean, the team is constantly working on these incremental improvements, and you will see more of that over time. Where native image will just get smaller and so on. I think we're just getting started here, and the project is still young. I mean,
it is hard to believe it's young. So GraalVM 1.0 came out in 2018, something like that. 1.0. So
that was 1.0, but it was like very early.
Oh, I know. I mean, even then, so that's the thing is, I remember I talked with you about this as well. We talked about the improvements in compilation time. I'm excited about what you talked about before, but I'm also, I as much as anybody remember in March of 2020, I did my first demo with Spring and GraalVM, our initial very early prototype phase sort of support in Spring back then. March of 2020, famously, nothing else happened that month. I mean, it was a 10-minute compilation cycle. If the pandemic had not come along, that 10-minute compilation cycle would have been the worst thing that happened to me that year.
Right.
It was very, very dispiriting. But now it's like 30, 40
Yeah,
seconds. It's nothing.
Exactly. No, we improved it a lot at scale specifically.
We did a little bit as well, but you guys,
we improved it a lot at scale, and there's still more to be had there. Working on it is really very great people.
The best.
And you don't see them so much in the foreground because they prefer to kind of do the actual work.
I mean, I as long as I can, I'm gonna be making sure people know Dr. Fabio Niepaus. You know, like that guy makes me laugh so much. But so that brings us to you've got Java doing things nobody thought it could do. It's a lot more efficient, a lot more productive, a lot more performant, a lot more scalable. What can you do for other languages? And this is one of those things where my understanding was that you had this polyglot truffle sort of story before, but I didn't really have particularly great success making that work with native image, and it's like a fork in the road. I could use the polyglot VM or I could use native image. I know in theory I could do both, but I never really had great success. I'm an idiot though. I don't know what I'm doing. But now, oh my goodness.
Yeah. No. We like the polyglot story is still also live as Graal. We want to run multiple languages.
Yeah.
And what we did now is one of the things we did in this area is that we focus now on very specific languages, and this is Python, JavaScript, and WebAssembly.
And by the way, you worked on the JIT for Chrome.
Yes, for the Chrome browser. I worked for the first optimizing JIT for V8. Was released somewhere in 2011, and that's when I got my JavaScript JIT experience. Right. And that was sort of inspired to say, like, okay, when I'm writing a Java JIT, it's actually very similar. Why don't we use the same JIT technology for both things? Right? It's about just as a natural instinct of software developers for reuse.
Re-abstraction,
yeah, reuse abstractions, right?
But unlike Parrot, remember Perl 6?
Right.
Unlike Parrot, this actually shipped.
This actually shipped, and we're still going very strong in this area. We just consolidate currently on Python, JavaScript, and WebAssembly because we think those are the most popular languages people want to work with. And in the last release of GraalVM, those are now production ready. And what we did specifically, we improved the developer experience for deployment and for configuring the system.
Right.
So you can now, in your Maven POM XML file, you can specify your Java dependencies, but you can also specify your Python dependencies. So it turns out Maven is a multilingual build system. And then with one command, you can also build a native executable that has Java in it, but it also can run Python, and it also has the Python code in it. You will have one contained executable with a Java runtime, Python code, and everything can be shipping as one native image.
And then WebAssembly, which you can compile to from Rust and Go.
Yes.
I can now consume that from I can run that as a native image?
Yes, also that. Like you can also have WebAssembly that was generated from Go, Rust, etc. And you put them into a native image as well. In the same way you can do it for Python and JavaScript. Right. Yeah. So this is early technology as well. We're working on it for some time, but now we think it's production ready.
Right.
If you want to try it, please give it a try. Give us some feedback. Be nice to the system because it's still early.
Yeah.
But it's absolutely ready to be tried out on your environments, and give us the feedback on where you want to push this.
And this gets us to the last thing, which is those environments today are very different. We have ARM. I'm recording this off of an ARM Apple Silicon device. We've got RISC-V. You've got support for that. These are Intel's very different, very verbose comparatively. So having the native image be aware of all that and being able to optimize for each of those microcodes is super cool. But then to be able to do all that while also preserving the right ones running anywhere semantics of Java,
yes,
just blows my mind. Well done.
Yeah, no, it's really cool tech.
What's the so you mentioned RISC-V? That was like last year. I remember in January of 2023, you talked about that, and then. What other environments have we added support to? I know we got Mac, Windows, Linux, we got Intel, we got ARM, Apple Silicon that's working fine. Right.
We have one company we're working with in Germany that has a 32-bit port because they go for embedded devices. Right. It's Microdoc.
Right.
They go more on the crazy level. I asked them if they can do a ESP32 controller, but they said it's currently still a little bit too small of an environment. But you can certainly go also in this embedded space a little bit, and then we have an LLVM backend,
right?
Where you can then sort of reuse the LLVM backends that are available. And
wait, so you can compile to you use LLVM bytecode.
bitcode. Yes,
Yes,
you can
bitcode.
compile to LLVM bitcode, and then you can go further, right? And then the final thing we're working on is, well, we are now supporting WebAssembly as a backend.
Wait,
As a backend.
okay.
As a backend, so we can run WebAssembly
In the
on GraalVM,
right.
but we can compile a native image into WebAssembly.
Wait,
And then you can run your native image as WebAssembly in your browser.
so wait, can I do that with the Spring app?
Yes, also maybe some of the APIs there with networking and so on, they might not be.
But still, like, in theory, I could do public static void main
Yes.
and build some things. Is that available today, or like, do I need to know anything to do it, or
That is.
this is being recorded, right?
Yes,
like people can hear you.
Yeah, no, that is in the product today, but it's, we don't talk about it too much yet because WebAssembly is an evolving standard, and one of the things they add is the WebAssembly garbage collecting section.
Yeah.
And currently we are targeting WebAssembly without garbage collection, which gives you a slightly less good performance.
Yeah, but it's still.
But the team is working on making it that you can target WebAssembly with the garbage collection extension. And when that is shipping, and it should be very, very soon, then we're going to talk more proudly about it, and then we will let you demo it on stage.
Because that is so cool. Because you talked about, there was like a little hint of that 2 years ago in January of the RISC-V announcement, and the very bottom is like, this might have implications for WebAssembly. I'm like, that's the lead. That's what I wanted to hear about. And you're talking about RISC-V, which is great, but this is what I want. Hey, we're actually did I mention we're at Devoxx? We're at Devoxx, and we're actually in a session. So there might be background noise. We're going to wrap up here pretty quick. Thank you very, very much.
Thanks, Josh.
You're amazing. Your team's amazing. Check out GraalVM.org.
Yes.
Yeah, and your Thomas WUE, is it?
.dev, yes.
.dev on. Bye, everybody. Stay tuned for more. I'll see you later. Did it work? I don't know. In stream? Are we live?